We have an example problem here. Two identical tuning forks oscillate at 440 hertz. A person is located somewhere on the line between them. Calculate the beat frequency as measured by this individual if she is standing still and the tuning forks move in the same direction along the line at 3 meters per second. Okay, so both of them individually they oscillate at 440 hertz. So let's say I have tuning fork 1 here, tuning fork 2 here. The person is somewhere in between them. Now we're going to have both of these tuning forks move in the same direction at 3 meters per second. And we want to know the beat frequency this person would hear. So as soon as the motion starts, the person is going to hear something different. So F1, they're going to hear something lower than 440 hertz because tuning fork 1 is moving away from this observer. The observer's not moving. The observer's the person. The tuning fork 2, they're going to hear something higher than 440 because the motion is towards. So we need to use the Doppler effect to determine what frequency is heard. So I'm going to set up the equation. This is the one I remember off the top of my head, the one that accounts for both observer and source moving. Of course, the observer's not moving, which is fine. So the frequency 1 that we hear, the actual frequency is 440 hertz. They haven't told us anything about a temperature, so I'm going to go ahead and just use the 343 meters per second for the speed of sound. The source is moving at 3 meters per second, and since it is moving away from me, or the person, I should say, I use the positive sign because that's the bottom sign in the denominator. So away is always the bottom of the two signs shown. So as this person that's holding tuning fork 1 is walking away, we will hear a frequency of 436. I'm going to keep a couple digits here since I'm going to round to 3 sig figs. I want to keep more than 3 in my intermediate steps. So 436 is what we hear as the person walks away. The one that walks towards, the only difference is that we'll subtract that 3. .88 hertz. So the beat frequency is the difference, the absolute value of the difference between those two. So I'm going to just take the bigger one minus the smaller one, so I go ahead and get that positive number. So 7.697, so 3 sig figs, 7.70 hertz, or 7.70 beats per second. Either way is fine. So the person in the middle would hear that wah-wahing 7.7 times per second.